Imagine falling into a black hole. You wouldn't just be crushed, you would be stretched, torn, and then impossibly, your entire existence would become inextricably linked to a single direction, forward, towards an unknowable point with no way out. Black holes are the universe's ultimate cosmic enigmas, regions of space-time where gravity is so intense that nothing, not even light, can escape. They are born from the catastrophic collapse of massive stars, leaving behind a core of incredible density. But what truly lies beyond the point of no return? That point is called the event horizon. It is not a physical surface, but rather a boundary in space-time. Cross it, and the escape velocity exceeds the speed of light. From an external observer's perspective, an object falling towards a black hole would appear to slow down, its light reddening, eventually freezing just above the horizon, never truly seeming to cross. For the unfortunate traveler, however, the journey continues unimpeded, at least for a while. As you approach the event horizon, the black hole's immense tidal forces begin their terrifying work. The gravitational pull on your feet, closer to the black hole, would be vastly stronger than the pull on your head. This differential force would stretch you like a piece of spaghetti, thinning and elongating your body until you are nothing more than a stream of atoms. This process is known as spaghettification. Beyond this gruesome stretching lies the true heart of the black hole, the singularity. General relativity predicts that all the mass of the black hole is compressed into an infinitely dense point of zero volume. At this point, the laws of physics as we know them completely break down. It's not just a place where things are very dense, it's a place where our mathematical models yield infinities, signaling a limit to our current understanding. Inside the event horizon, something even more profound occurs. The roles of space and time swap. Outside, we move freely through space in any direction, while time marches relentlessly forward. Inside, the direction forward in time becomes synonymous with moving towards the singularity. There is no longer a path that takes you away from it, just as there is no path that takes you backward in time. All paths inevitably lead to the central point of infinite density. Yet, black holes might not be eternal cosmic prisons. Stephen Hawking proposed that black holes emit a faint glow, now known as Hawking radiation. Due to quantum fluctuations near the event horizon, pairs of virtual particles and antiparticles constantly pop into existence and annihilate each other. Sometimes one particle falls into the black hole, while its partner escapes, carrying away energy. Over unfathomably vast timescales, this process could cause black holes to slowly evaporate. This concept introduces the notorious information paradox. If a black hole evaporates, what happens to all the information about the matter that fell into it? Quantum mechanics dictates that information can never be truly lost. If Hawking radiation is purely thermal, it carries no information about what created it, implying information is destroyed. This fundamental conflict between general relativity and quantum mechanics remains one of the greatest unsolved mysteries in physics. Despite their elusive nature, black holes are not just theoretical constructs. Through the Event Horizon Telescope, an Earth-sized array of radio dishes, scientists have captured groundbreaking images of the supermassive black hole at the center of the galaxy M87, known as M87 star, in 2019. In 2022, they revealed the first image of Sagittarius A*, the supermassive black hole at the heart of our own Milky Way galaxy. These images don't show the black hole itself, but its shadow, silhouetted against the glowing hot gas of its accretion disk. Black holes are not merely cosmic destroyers, but extreme laboratories, pushing the boundaries of physics to their absolute limits. They are where space, time, gravity, and quantum mechanics collide, challenging our deepest understanding of the universe. What's truly inside a black hole? Perhaps an entirely new dimension of physics waiting to be discovered. Subscribe for more journeys into the cosmos.